Hello and welcome to week 5. This week we're going to cover Python. And it's hard to try to figure out to go to Python or EDA first. Normally in other projects I've covered EDA before Python. And the reason is that normally you use Python a lot of times to do EDA. EDA is where you kind of look at the data, figure out what's valid, what's not valid, what's missing, do we have a lot of nulls, things like this. We kind of what's the need? If we're looking at an age demographic, here's a great example. If we're looking at something like a Medicaid, where we know people have to be in theory over 65 to be on Medicaid, or Medicare, they have to be over 65 to be on Medicare, and the average age is 42, we know something's wrong with our data set. If we expect the average high school, if I take a high school and, I expect the average age of a person to be in high school, maybe 16, 17, and I do an average and they're 28, I know something's wrong with my data. That's kind of the gist of EDA. And it's hard because normally a lot of times we use Python, but not always. So why did I put Python before EDA this time? And a lot of the reason is because the more you understand that Python is just another tool, the easier things will be. The more you'll be able to leverage that tool. EDA is a process. Python is a tool. Tableau is a tool. Alteryx is a tool. SQL is a tool. Some tools have strengths, some tools have weaknesses, some are better than others. But at the end of the day, it's still just a tool. And let me show you what I mean. I saw a Twitter question a couple days ago, and I just think it's very relevant to this conversation. Let me see if I can zoom in a little bit. Okay, so this Twitter thread was, 5 days ago, 6 days ago, I guess now. Folks who use SQL or Python for data analysis, why do or don't you use point-and-click products to do analysis? And it doesn't matter what the product is. He goes, and then he continues on, I've observed a clear divide between technical and non-technical folks in my career so far. It's a great question. Why do we use Python, or why do we use non-GUI based graphical user interface tools, or when do we use those tools? And in terms of the business intelligence, here's one of the best answers ever. Basically, if you can't express what you want in words, no amount of clicking will get you the right answer. If you can express it in words, it's not a big leap to express it in code. So let me go back to webcam. So somebody told me once that without a fundamental understanding of statistics, you can get the right answer to the wrong question. You can use the wrong type of statistical tool and get the wrong and get a correct answer, but to the wrong question. You don't understand what the statistics are telling you. And this is very, very true with this. Okay? A lot of times when people start doing, and they call it data analysis, I would call it more business intelligence. When they start doing business intelligence, you have to really understand what are you there for? What are you looking for? What are you trying to validate? What are you trying to interrogate? So it talks a little bit more about, some people who use Tableau in here. Some people use Python, some of the pros and cons of it. Data is never clean. Anything beyond a sum of cubes requires custom code. Performance. Now sometimes Tableau for me has been really fast. Sometimes Python's really slow. Vice versa. Sometimes Python's inherently fast. Sometimes Tableau is really slow. It just really depends on the code. I use both. Next week, when we talk about EDA, I found a Reddit poll that says, "Hey, how often do you use Tableau for your EDA to interrogate data?" And it came out about 50% of the time people use it because again, it's a great tool to use EDA to interrogate data. But let's talk about a little bit Python here. Now, what have we done so far? Well, we've covered SQL. We've covered Power BI and Tableau, basically just high level, kind of how to do things in it. I don't believe in, holding your hand, teaching A, B, C, and D in Tableau or Power BI or SQL, because in 10 years when those tools change, if you only know how to do that, it's horrible. One of the comments in that Twitter thread was like, you don't ever want your career to be based upon a vendor-related product. And it's true. You don't, because those vendor-related products change. So where does Tableau shine? Where does Python shine? That was totally my bad. At the end of the day, Python is just a tool. It does really well at data collection. We did a lot of this with SQL, and it does, you can use Python in addition to SQL. You take SQL, export to CSV, and use it through Python. But Python does really well at data cleaning. EDA, we'll talk about that next week. But one thing that Python can do really well, and I guess SQL can too, is a certain type of, it's not really feature engineering, but if I give you a date, in the demo I have a date, and I want to know what day of the week it is. How easy is it to do that in that product? Classification. Now, Tableau, Power BI, I don't think SQL can. Alteryx can. A lot of other programs can do classification and regression and clustering, but how many different flavors of it can it do? Can it do ridge regression? Can it do different types of regression? What type of clustering does it do? Python excels at all these. We talk about dimensional reduction, PCA, T-sign. Python and R, for that point, are really the go-to languages to do to do dimensional reduction. And eventually, after the midterm, we're going to go a little bit into machine learning. And with machine learning, well, you can do machine learning in C and Visual Basic and Ruby and a lot of different languages. Python is a bulk of machine learning. Probably 95% of all machine learning is done in Python. And why is that important? Well, you kind of have to understand that there's two kind of points in the world of data. There's data looking backwards, financial analytics. Hey, how much money did we make last quarter? How many products did we ship last quarter? Or there's predictive modeling. How many products are we going to ship next semester? How many products are we going to get refunded? Things like this are forward-looking things, and that's where machine learning a lot of times has a strong advantage, is predictive modeling. And in that predictive modeling, it's Python. So now, I've tried learning other languages. I've never been great, and Python came more natural to me, and I don't know why. It could be that Python was very easy to learn. Its syntax is very clean. It's very simple. You can almost read it like a book. Python has a lot of different libraries. What I mean by libraries are ways to extend what Python does. So if you have a car, well, certain cars have more mods than other cars. Toyotas and Hondas tend to have more mods than maybe Maseratis. Okay, so it's just as that example, Python has a lot more libraries than Ruby has gems, or these other programming languages have extensions built into them. Additionally, Python is open source. Now, why is that important? Well, that means it's free. You know how it's built. You know about it. Where vendor-related products aren't always open source. They could be locked down. You may not always have it. We have a product that, and this is funny and horrible at the same time. We have a product, and I guess our team, or our national corporate team, discovered a security vulnerability in it. We have the ability to fix that security vulnerability. So we found a problem in basically a vendor product. We have the ability to fix that vendor product, but we can't. And the vendor will not even acknowledge that the problem exists. Yet we have video and documentation showing the problem exists, and it's a security threat. So this has become a bigger and bigger issue where we're like, well, we're going to have to pull your product. You're going to lose hundreds of millions of dollars a year. And they're like, well, there's no problem, because they don't want to openly admit that there's a security concern with their product. If it's open source, we could fix it and post it to the world, and it would be a completely different process. When it's closed like that, when a project or a program is closed source, that's not always a bad thing. That just means there's no transparency. Now, this is one of the hardest things to explain. But the way I always think about it is you don't need Python until you need Python. I know that seems like an oxymoron. So what do I mean by that? I mean that most of the time, Tableau will do. Most of the time, Ultrex, SQL, any of these other R will do until it won't do. There was one of the comments on that Twitter thread, why do I use SQL and Python? Well, one of the reasons I use it is I don't want to get to 90% of a project, then have to retool to Python and SQL because I'm using a vendor product. Okay, and let me explain that a little more in detail. I saw somebody wrote some Python code, and I thought it was just a great example. So let's say that the College of Business said, hey, Richard, we want you to start keeping track of everyone that shows up for these Zoom meetings. You have to do attendance. Well, at 20 students, 25 students, that's not too bad. I probably could do that. Say, hey, this person came in at this time, this person left at this time. It becomes a little burdensome, and the administrative load is kind of unnecessary, but we could do that with 10 or 20 people. I could assign a student extra credit and say, hey, just keep track of who comes to the Zoom meetings and who doesn't. Not a big deal. I was in a meeting on Tuesday with over 700 people. I think I had about 730 people in it. And people coming and going and go, it was just horrible. And again, everyone's muted, but you can see the little number on the top of the screen. 640, 680, 700 people, 650, and it would keep jumping up and down every couple minutes. So how would you track that? If I was your boss and I assigned you a task, I need you to track 200 meetings with at least 500 people in it every week. You couldn't do that by hand. You'd have to automate that somehow. But Tableau can't really do that. And I doubt that Zoom or WebEx is just going to give you, SQL access. So SQL is out of the question. Power BI is kind of out of the question. So let's see. Well, you know what? Somebody wrote a script in Python that integrates with Zoom's API and does that. And it's beautiful. I haven't tried it, but I looked at his code. It looks great. So it will say, hey, here's a meeting from Monday at 9 a.m. to 10 a.m. Here's all the rest of the people that came to the meeting. Here's when they got there. Here's when they left. Beautiful attendance record. That can only be done in Python. I couldn't think of another way to do that. Maybe JavaScript or something else. But basically, you still need to program out a solution. So that's what I mean when I say you don't need Python until you need Python. So let's talk about some goods and bads of Python. And I'll say pretty much everything's good except for one bad, to be honest with you. So Python can do almost anything. Python has a huge development community, a huge educational community, huge support community, so it can do literally anything. If you think of it, probably somebody else has done it in Python. We can automate all types of things, all different types of workbooks. One of the students had a question, and I exported to a hyper to Tableau. I've never exported to a Tableau directly from Python before. Normally, I just do a CSV, but I exported to a hyper, and boom, it was like 1 or 2 lines of code, import a library, and boom, it was super easy. So if you can think of it, Python probably can do it. I use it personally to test theories. And I have a slide, a couple slides down, where I talk about different types of reports and maybe where Python's good and where Python's bad. But how do you know if your idea is good or bad? And it's an honest question. How do you know if your proposal is good or bad? How do you know if these things are good or bad? The only way to really do that is to dig in and run an example code, run some numbers. What does the data look like? In theory, you can kind of try to figure it, but it never works. You're going to have to just start digging in and figuring it out. And the best way to do that, a lot of times, is just to use Python and do a real quick sketch and move data around and see if things work. An example of that is on the demo. I I was doing the demo and then I had a problem. And I couldn't figure out what the problem was with my demo. It should have worked super easy. I just had to sort something, alphabet 1, 2, 3, 4. I mean, super simple sort, and it didn't sort right. And then I remembered that, hey, my numbers aren't an int. They're not a number. They're a string. So the machine doesn't know how to sort them right. So that was an easy enough fix. But if I didn't play around with Python, if I didn't interrogate that, and I would have handed you that homework assignment, you would have fought with that for hours. So that's what I mean. It's good to theories. There's great communities, lots of educational stuff. There's Stack Overflow, there's Medium, there's tons of sites. We all have access to LinkedIn Learning. ChatGPT, Copilot work great with Python. They work good with other languages like Ruby and Perl and JS, but they work really good with Python. Now the bad. And really the only thing I'm going to say about the bad is security issues. Because I want you to be aware of this. I'd be remiss if I didn't tell you this. So Python itself is very secure, at least in my mind for the most part. However, the problem is packages. So when I helped that student and I installed the Tableau package, did I know that that was a safe package? No, but I'm not dealing with really sensitive classified information. I don't work for the CIA. At work, I probably would have never installed that. But when you install a package, what do you really know about the package? Did you look at the code? It's made by somebody else. Most of the time they're open source, but packages are often the security weakness because people tend to install 1, 2, 5, 10, 15, 20 packages and not really audit those packages. And when those packages aren't audited, and it's not really our job as business intelligence or data scientists or data analytics people to interrogate those packages. That's the job of cybersecurity people. We just assume those packages are safe, and a lot of times they're not. They could be leaking data back to the person that created it. Here's all of this in a little bit more detail. Like I said, Python is loved for a lot of good reasons. Can do a lot. We'll talk about NumPy. We'll talk about scikit-learn. So there's a book which we'll talk about a little bit. It's called Automate the Boring Stuff. That book talks about using Python in a business environment, or at least to automate things. And that's where Python really, really shines. Even in today's big companies or small companies, for some reason, you always have somebody that's got to take these 2 or 3 Excel sheets and merge them, or do a pivot table, or do something in Excel. And it takes forever. And then they have to email it to somebody else. And it's a horrible process. Okay? There was a process like this at work where we looked at hours versus overtime hours and training hours, and we have different levels of time. So you work 40 hours, but maybe 10 hours of it is training, so we have to subtract that. It's a horrible process. So what we do is we use a Python script to kind of summarize each individual employee's hours every 2 weeks. And it saves hundreds of hours. I mean, there's 5,000 some employees that I have to run the script through. And to do it by hand will take just an enormous amount of time. Here at UNLV last week, or the week before, I think maybe 2 weeks ago, one of the other professors outside of the College of Business had 40 or 50 patients. Okay, and of the 50 patients, each patient had 16 files. So maybe, well, they had 304 total files. Okay, so basically what they would have to do in their Excel files, they'd have to go down 150 rows and do an average, like 2 or 3 average, but do an average. Go down 150 rows, do an average. Go down 150 rows, do an average. One file was taking 2 hours. One file, 2 hours. They needed those 304 files processed by mid-October. Even with 2 people, 2 students, graduate students, it wouldn't be done until maybe the first week of December. 2 hours, 3 hours of file, 300 files. I mean, you can do the math. It's already mid-September. It was not going to happen. I saw them struggling with this project, and I injected myself into this project. So it probably took me 15 or 20 minutes to write the first sample code to make sure I could actually do it. I wasn't sure I could do it, but I did it, and it took me 15 or 20 minutes to write the first file. It worked great. Then it took me another 15 or 20 minutes to go through and write more code to grab all the Excel files. So maybe about an hour worth of programming. Then I run it. I have to debug it a couple times, so maybe 2 hours of my life. It processes 304 files in under 2 minutes. So 2 graduate students would take to December doing it by hand, or we could use Python, take 3 minutes to run it. Even with my time to do it, it's less than a day. And this is where you as a business intelligence expert, this is where you as a data analyst, data scientist, it doesn't matter. This is where you can really shine at work. If you can find a way to take something that takes 40 hours and condense it down to 2 hours, you can find something that's some process that takes days and condense it down to no time at all, it makes it a huge value to you, the company, everyone else. And this is where Python really shines compared to Alteryx, Tableau, Power BI, and other tools. Now, so far up until now, when I talk about Python, and I'll show you some Python script and some notebooks, I've been talking about just traditional Python scripts. That thing that processes 300 files is just a regular old-fashioned Python script. Now, notebooks, there's something called Jupyter Notebooks or RStudio or Colabs or Paperspace, Azure Notebooks. They're fundamentally changed the way that Python runs. It chunked it up. And I have another slide that will talk about this. But this change has made programming accessible to the public because we can add notes easier. We can see small chunks. When you have 5,000 lines of just text, it's impossible to debug. Well, it's not impossible, it's just very hard. So let's talk a little bit about the Python basics. Again, there's tons of resources on the internet. Whenever you see anything in front of you, I always want you to think, hey, is this column, and it's hard because it's not natural for us to think like this. Is this column, is it truly an integer? Is it 5, 6, 12? Is it a float? 3.14? Is it a varchar? Is it a variable string? Is it A, B, C? And now, what do I mean by that? Because a number, the number 1, can be a string. Now, it shouldn't be, but it often is. And what happens? Well, the problem I had just earlier today, when I found that problem in the homework, is basically when I sorted what I thought were numbers incorrectly, and I wanted to sort 1, 2, 3, 4, 5. It sorted at 1, 11, 12, all the way up to 19, 2, 20, 21. And so the sorting was all weird. But that's how you sort a string. That's not how you sort a number. And here's that link to that book, Automate the Boring Stuff. I don't normally recommend things, but it's a pretty good book. I think it's free. You can get it online free. I think the first version I went through was free. Then eventually I bought it. He has web classes and more. So I said there, the next slide is going to basically talk a little bit about this. So all programs are basically some type of flow control or control statements, and those are if this, keep doing it until this, or a Boolean expression, keep doing it if this is false. If it's under 100, keep going until it's true that we're over 100. So you're always got to think in the back of your head, control structure, or I think it was flow control, but basically it's how do we control the operation of a loop? How do we keep going over a loop? Okay, is it a true false? Is it until then? If this, then that. Like I said earlier, Python at its heart is not a compiled language. You hear that term with C and Rust and other languages that are compiled. They use a compiler. You have to use an IDE, more than an IDE. You have to use a compiler. That's actually the word. And you take your code, you write it, and then it compiles it. And if there's errors, it spits it back out at you and says, hey, this is not right. The advantages of compilers is that a lot of times you don't need libraries. You don't need to install libraries from the end user's perspective. they can run faster. They're closer to the true machine code. Now, with interpretive languages like this, it reads it one line at a time. So if it finds an error, it will tell you, in theory, right then and there where the error is, hopefully. Interpretive languages like this, I think, are a little easier to understand, a little easier to read. It's more of a native understanding. And what do I mean by that? So if we think about the way language used to be structured, okay? Language, in my mind, almost used to be like this compiled thing. So this right here, NEQVEP, is the same as this. Just has no spaces. Older books, older English, older writing, not English, but older books didn't use spaces, didn't use paragraph indents. They just wrote and wrote and wrote in the margins everywhere they could. And they made it very hard for them to translate into actionable words because there was no breaks in it. Python now has these breaks. It's formatting, it's syntax. Okay? And since it has markup, I guess would be the word, we can say that, hey, here's a return. We know something else is happening. You know, while we may not get as much density on a page when we use returns, we use tabs, we may not get as much code as humanly possible. That's okay. It allows us to read it. Let me keep going a little more. There's another term that it's called the Zen of Python. Let's see where there. The Zen of Python is the idea of good coding practices. Now, I can't. There we go. So the Zen of Python, they're just suggestions. I'm not the best at them. It's something I would like to strive to. I'd like to be better at. You see, they're from 2004. But let's just go on a couple of random ones here. Beautiful is better than ugly. And they're talking about just the formatting. We were just talking about this, instead of having everything big blocky text that's unreadable, it's better to have some type of frame or code or structure around this. And if you don't believe me, let's talk about Tableau. Why is Tableau popular? Why is it a multi-billion-dollar business? Excel can make charts. Excel can make a lot of these line charts and pie charts and bar graphs and histograms because Tableau can do it prettier. And that's really one reason why. It's prettier. It's beautiful. So in order to, and to have something that's readable and have these little indentions, have, code that we can read, that's easy to read, is vital. Okay? And this goes on to a few other things I'm not going to really go into. You can read it. And I would love to be able to follow every line of code and make all my Python zen and nice, but you can't. But the thing is, that's not to say that you shouldn't try or keep them in the back of your mind. And the same thing is true with business intelligence. Okay? Special cases aren't special enough to break the rules. And we're going to talk about ethics. That's ethics right there. Special cases aren't special enough to break the rules. Readability counts. If I have, if you submit your research proposal next week, I can't read it, you're not going to do well on it. Here's another one. We were talking about your research project. Now is better than never. Well, it's better to get a D on your project than not to do it at all. It's better to get a B minus than not to do it at all. Now is better than never. Now it's talking there about a loop, but still, these are all things that can be translated into business intelligence as a whole. So you can just type Zen of Python, you'll find it. So if you ask me, one of the things that really made, I don't even think notebooks were originally designed for Python, but one of the things that really made Python popular were notebooks. Notebooks allowed non-programmers or weak programmers, maybe data people like me, to really embrace programming. So instead of having a big old long line of code, we could chunk it up to smaller parts. And I'm going to do a demo real quick to show you a couple different notebook types. But at the end of the day, a notebook's still just a way to break up code, a way to document. You know, I use Visual Studio Code, I use Colabs, I use Jupyter Notebooks, I use Kaggle. I don't really use Paperspace too much anymore. These are just the ones I can think off the top of my head, and Azure Notebooks I use. And there's some differences. There are. Like MS SQL, MySQL, there's differences. But if you can drive a Ford, you can switch over to a Chevy, drive a Chevy. If you can drive a Honda, in theory you can drive a Toyota. There's differences. I'm not going to deny that. But some might be better than others, some might not be. But again, at the end of the day, they're still notebooks. So let me show you some code here. Desktop zoomed, and I think I have a. So you have and this is not even really that complex of a code. It's just something I found. But I mean, look at it. You're like, well, here, what's going on here? What does this do? Well, here's, and I even got comments in here. And it's just horribly ugly to understand. I think this one. Nope, it was this one maybe. I have another one here too that's just horribly ugly to read. Okay, so let's look at what that looks like in a notebook. No, my notebook for that would be right here. There we go. Okay, let's see if we can move this over here a little bit. Okay, so a notebook, this is Colabs. You all should have access to Colab. Okay, like I said, yours might not have the cat and stuff anymore. Yours might look slightly different. But you can run different parts of this and get it to work. See, that one worked, this one doesn't. I can do different things. And when I get errors, and you can also document, extract images. So maybe I want to add a little bit more notes. So extract images. This block saves the images to the Google Drive for processing. Something like that. So we can document. So not only can we document individually inside the code block, we can also document here outside of it. And we can also turn on and off little like chapters. We can hide things, which, believe it or not, becomes really nice when you get really big notebooks. Let me load another notebook. So this is Colabs. Let me grab Visual Studio Code. So this is Visual Studio Code. Let me make sure I get it all on screen. I drop down just a little bit, okay? There we go. And so, just like the other thing, you have these little notebooks right here. Say, hey, I want to add code. Pib. Oh, if we can type today. Oh. Pib install OpenCV. Okay. So you can actually, write code in there. Or you can add text, and say, hey, need to write a script or write code to install the correct version of OpenCV. And all that, so you can say, hey, this needs to be version, oops, spelled that wrong, version 3.2 or higher. Okay. So I can write code just like I could with Colab inside the code block, or I can make a little markdown note above it. This finds files, something, whatever, in a directory. Let's look at the original Jupyter Notebooks. So I have to get launched here. So here's a Jupyter Notebooks. Let's go new, Python 3. What do you know? It's just like the other thing. The other notebooks, not the other thing, the other notebooks. Pib install OpenCV. I don't think it will run. Yeah, exactly. Pandas. Boom, see, it's working. There's also a newer version of Jupyter Notebooks called Jupyter Labs. Try to start now. So Jupyter Labs is just like the fancier version of Jupyter Notebooks. So different environments, like different content environments. Select, still do the same thing, pip install NumPy. Um, let's try Scikit learn. I don't think it's something else. Oh, maybe it is Scikit learn. So there you go. So again, these notebooks are just ways to, and you want to add code below. See, look. Then, maybe pip install, even though it's installed. So you get the idea. They're all fundamentally similar. There's slight differences. So let me move back here. Yeah, I know what I said. So again, I highly recommend using either Colabs or Visual Studio Code, anything you're familiar with. Colabs is nice because there's no setup. It has a lot of packages installed. It works good. So I presented this slide 3 classes ago, and I kind of wanted to circle back to it. So when I talk about Python, at least in my mind, and I could be wrong, because there's times where you maybe use Executive Dashboard, you use Python. But at the end of the day, if I say, hey, here's where it's more likely to use Python, where it's less likely to see Python. In my mind, I would say operational reports, you're more likely to see Python. Why? Well, because sometimes when you do day-to-day reports, you want to take those reports, email them out, or you want to send them to a phone, or you want to do something with them. They want to trigger some type of automation. So you're low on paper for your printer, and maybe you can have a Python script automatically order more paper. Or the Python script can email somebody to order more paper. Things kind of maybe outside the scope of Tableau. Now, management reports, executive dashboards, Power BI, Tableau, these are all great programs for those. You don't always see Python in those. Regulatory and compliance reports. Very common to see, some type of Tableau or some type of system and also Python. Why is that? Because a lot of times you have to upload that data somewhere. You might have to, I just saw a report where we had to upload data to the state of Nevada. Yeah, the state of Nevada. I just saw the email. And I guess our username password didn't work. And it's funny because the password expires every 90 days, but we only upload data every quarter, every 180 days, something weird like that. And if you actually thought about it, it was like the stupidest thing. They should make the passwords expire every 6 months, and we wouldn't have this problem. We upload at a quarterly cadence, and the password expires, I think, maybe in 30 days if we don't use it. And you can't upload it more than once. You just upload it and you're done. So we have a Python script that basically uploads it all. So, it's kind of common to see Python and those type of things. Maybe you're a casino regulator, or you're a casino, you're aristocrat. You have to upload your slot machine winnings to the state. Very common. Maybe you're some type of food vendor, and you have to upload, your sensors for your temperature for your freezers, things like that. Also, predictive and forecasting reports. Maybe you do the data, and you get the data from other sources from a data lake, but you want to know the future state of something. You want to use some type of machine learning. This Python is more popularly used. Again, financial reports. Excel is a big player in this, and Tableau is probably the big player, and Alteryx is probably the big player. But sometimes, some of these financial reports, they merge 2 or 3 different things together. And when they merge 2 or 3 things together, you'll see that Python can do it faster and easier. So this is just my interpretation of where you'll see Python. Maybe you only work on executive dashboards. Maybe you only do compliance reporting. It really depends on what you do. So again, like I said, this is not going to be a super long lecture. The demo is going to be a little longer than normal this week. So I want to talk about some libraries that you'll see. Pandas is very, very popular. It's probably the #1 library in Python. Pandas is, in a way, Excel for Python. Okay, if you have tabular data, if you have data that's like Excel, then Pandas is your friend. When I had to calculate an average of 150 frames, I used Pandas to do that. I loaded all of the frames. I loaded all the data into a data frame and just had Pandas calculate every 150 and just store it into a new variable and move on. It's very, very quick. 2 minutes. I think the longest time it took for you to optimize was like 3 minutes. It took 2 minutes instead of 2 months, 3 months. Pandas is and Pandas is not even the fastest thing. NumPy is faster for certain things. But like I said, you want to find all the nulls. You can do that with Pandas. You want to replace the nulls with 0. You want to find basic statistics. All these things are very, very easy to do in Pandas. Okay? So it is probably one of the most important data manipulation tools and data analytics tools. Now, as a business intelligence professional, you'll use Pandas in a lot of different ways. You want to know if that data that you have is valid. I looked at the number of cylinders, and then we'll talk about this in the demo. So I looked at the number of cylinders. I pulled like 100,000 rows and looked at the number of cylinders. So if somebody wanted to interrogate the number of cylinders, oh, look, 8 cylinders, 6 cylinders, everything looks good. The problem is, over the bulk of the data set that I pulled had no cylinder information. It was null. Like 40,000 out of the 100,000 I pulled were null values. That could be a big problem. It could be a really big problem. You're trying to make some type of business decision on that. Okay. NumPy. NumPy is more for math integration. It's multi-dimensional arrays. I don't know if I'd really necessarily say scientific computing, but it basically allows for linear algebra, reshaping of data. We use it a lot in machine learning. I have a comparison between the two. I straight up, honestly, I had ChatGPT make this and copy it. 2 things that are important, or 3 things that are important, is primary purpose. Pandas is data manipulation and analysis. NumPy, numeric computing, aka machine learning. Okay. Your data source in NumPy is an array. You're in Pandas. Most of the time you use data frames, sometimes you use series. In NumPy, you do mathematical machine learning operations. And in Pandas, you do all these things: data cleaning, reshaping, pivoting, filling nulls, things like that. The rest of this I'm not going to really worry about for you. A couple other things, a couple other packages that you'll see that are important to just at least know in the back of your mind is matplotlib. Sometimes I'll say mathplotlib, but it's matplotlib. Matplotlib is just making graphs. Seaborn just makes those graphs prettier. I know it sounds horrible, but it's very important to have charts that are visually appealing. Maybe you need to have charts that colorblind people can see, that have accessibility. Maybe you need to have more 3 dimensions on them. Maybe you need to have a certain color scheme. Matplotlib can actually generate the plot, and you can apply a Seaborn theme over the top of it, for example. Now, I did include scikit-learn. Now, one of the reasons about scikit-learn is, at first, I was kind of hesitant in my life to use scikit-learn. But the thing about scikit-learn is they have great tutorials. I love their site. Scikit-learn tutorials. It's not even tutorials you want, but I mean, tutorials are kind of nice, but there's examples which are better. So, hey, I want to build a classifier. Here you go. And they even have data sets. You just call their data sets, and boom, easy peasy, you get the data set in there. Okay, that's what makes, at least in my mind, is so nice. So let's go to examples. So what is calibration classification? So I should have thought about this more. So let's do k-means. Just so cool. Okay, covariance, cross, data set example. I guess this would be great, since I was just talking about. So scikit-learn with basically one command from scikit-learn import. So it's basically, you can import data sets. No downloading, no playing around with nothing. And boom, you have this data set. And you can literally launch it right here and start playing around with it. So this is, what at first, like I said, I wasn't a big scikit-learn. Now I love scikit-learn, because again, you want to import data sets, boom, just do that. Digits equals load digits, and then you have the whole digit library. The 8, 1, 2, things like that. You don't have to get a database. You don't have to do anything. Okay, ensemble, and I mean, look at how many different examples they have. They have the code. They have everything you need to do this. So you import data set, load diabetes, load all this, train the models, boom. I mean, I highly recommend scikit-learn, just to at least kind of know it, and again, it's examples. Not necessarily tutorials, examples. Data set, decision trees, classification. I mean, they have just hundreds of examples. I can do visualization, it's scalable. I guess it's easy to use. I guess it's just like Pandas, kind of easy to use. But for me, I fell in love with the tutorials and examples. That book, Automate the Boring Stuff, it's a great little reference. I think it's free online. It talks about, hey, here's a boring task that we do in Excel. Let's see if I can make it easier. Here's how I read and write CSVs. I mean, if you work in any type of business environment with any type of business intelligence, it's worth a quick read of that book sometime, maybe after this class during winter break. I've read the book a couple times. It's a great book. Another thing to keep in mind too is that Python integrates into both Tableau and Power BI. TabPy, so I've used it in Python where I've had to fetch certain parts of data that are beyond the scope of Tableau to fetch, then load it into Tableau. I'm trying to think what I did for the surgery center. So it loads it into Tableau, it makes it pretty, and then Tableau sends an email every morning to some doctors with a nice pretty visualization. Then Python sends a more detailed email out that's beyond that. So you can build Python right into Tableau. Same thing with Power BI and Excel now. I just haven't used Excel. So Python is built into these Power BI tools. So if it wasn't important, it wouldn't be there. I mean, they paid somebody hundreds of thousands of dollars to figure out how to integrate Python into Tableau, Python into Power BI, Python into Alteryx, Python into Excel. So it's worth knowing at least the basics of Python, being able to read it, figure out maybe kind of what's going on. So, yeah, as always, if you have any questions, please contact me. The research idea or proposal or what you're interested in, I have a video on that, remember, that you can view, is due the last day of the month. There's a research topic due. Again, everyone's been doing great on the research topics. I've tried a couple different styles of grading it. I think I finally got into the perfect flow of grading those research topics. So don't forget to post, and I think everyone's doing it perfect. I don't think I had any late replies last week or the week before. First reply by Thursday, and then follow up with your fellow students with insightful, helpful, or commentary by Sunday. I didn't, again, assign any homework this week because I want you guys really focusing on your research proposal. And then more demos this week. This is a demo-heavy week. And I just want to real quick reiterate about the researcher idea proposal. I have a friend at work who has problems getting things off the ground. And a lot of what it is because he expects his managers to take and share the same views that he does, and they don't. Their expertise is in something else. I don't know what, medical management, maybe medicine, doctors. So the reason that I want you to be successful with this researcher idea proposal is I want you to go out to your job in the future and say, hey, I want to try this. And this is why I feel it's important. And this is how it's going to help. Today, my boss asked me for, I don't know, 15 minutes, impromptu, basically, on this idea. And it had to do with changing the way doctors refer patients. And so I said, hey, here's what I'd like to experiment with. Here's how I'd like to do it. Here's how, once it's done, if it works, here's how I'd like to expand it to everyone in the United States. Once we expand to everyone in the United States, I'd like to publish on it. I'd like to give back to the community. So not just our company, every company in the world can use it. And I basically follow those 4 kind of steps that I outlined in the research proposal. Hey, this is what we're missing. This is what we don't know. This is kind of how I'd like to, I guess, play with the data. This is how I like to analyze it. This is how I like to move forward. This is how I like to scale it. And once everything works, in theory, if it does, I like to be able to give it to everyone. I mean, it's one of those ideas that can help people. So please spend time doing your research or idea proposal. Please do the discussion topic Thursday, Sunday. Everyone's been doing great with this. I've been very happy. I think I mentioned in last week's video, I emailed the assistant department chair and a couple other professors about just how happy I am with you guys' homework and your discussion topics. Everyone's doing really fine there. I appreciate that. And more demos this week. I don't know why I put the red X there. But basically, this is a demo-heavy week. So some of the demos that I'll go over this week, probably have to use some of that code for next week too. So if you have any questions, please contact me. Otherwise, have a great week and thank you.